Hello and welcome, everybody. Thank you for joining us today for our virtual meetup titled Introductions to Image Augmentations using Fast AI version 2. In this meetup, Sanyam Bhutani will introduce the new Fast AI V2 framework and cover the vision module of it. We will also take a look at how to best apply the API to different vision problems, along with a deep dive into image augmentations and understanding how they are useful. My name is Saurabh Kumar, and I'm on the marketing team at H2O.ai. I'd love to start off by introducing Sanyam. Sanyam is a machine learning engineer and an AI content creator at H2O.ai. He's also an Inc. 42 Economic Times recognized machine learning practitioner. He's also an active Kaggler, where he ranks in the global top 1% in all categories. Sanyam is also the host of the very popular Chai Time Data Science podcast, where he interviews top practitioners, researchers, and Kagglers. Without further ado, I'd now like to hand it over to Sanyam.
Thank you for the kind introduction, Saurabh. Let me quickly share my screen.
Yes.
Okay. I'll start by sharing my slides, but just before that, I want to point out that everything I'll be referring to is picked up from docs.fast.ai. So if you want to check that out, please head over there. And the course I'll be referring to has just launched. So head over to course.fast.ai. I'll of course be talking a lot more about it, but just wanted to point these links out before I got started. Okay, hopefully everyone can see my slides. Hello everyone, good morning, good afternoon, good evening. Thank you for joining. I want to introduce the new FastAI V2 framework. I'll be talking a lot about FastAI, the course, the framework, and giving an introduction to the API, the framework, and also doing a walkthrough of how can you do image augmentations and image augmentations in general. Don't worry if you're not familiar with these topics. I'll be talking more about these, and you can of course ping me later anywhere on the internet, and I'd be happy to take any questions. So a few words about H2O.ai. I work at H2O.ai, and our goal is democratizing AI. Today I'll be talking more about the community. We have a few open source packages with the industry leaders in open source. So if you're curious about them, please head over to our GitHub profile. You can find our open source frameworks there. And I assume everyone is joining from the community. Just want to point out that we've recently crossed the 180K mark on the meetup page. So if you're excited about our mission, which is democratizing AI, and if you want to attend more meetups along those lines, please keep an eye out on our meetup pages. The other exciting part about meetups at H2 is you can get a hold of a grandmaster even almost all of the time. Many of our grandmasters are presenting during many of the meetups. I do apologize, this deck is slightly outdated. A grandmaster from Turkey has recently joined our team, just another Monday at S2. But we have another grandmaster who has recently joined the team amongst all of these. And our goal is to make any company an AI company. Again, you can head over to our website to know more about all of these details if you're curious. So let me start by talking about fast AI and clarifying a few jargons. What exactly is fast AI? Because there's a bit of confusion. Even for me, there was a bit of confusion when I was getting started. I'm maybe opinionated, but fast AI is one of the best deep learning courses and machine learning courses on the internet. That's my opinion. Maybe I'm a bit biased. It's also a research lab. It's also a library. So all three things are known as fast AI: the course, the library, the framework, and also the community. There's also community, one of the most active ones that I'm pretty active in. All four things are referred to mostly synonymously as fast AI. The fast AI that I'll be talking about today is the new framework. I'll be doing a code walkthrough of the API, followed by a code walkthrough of image augmentations, and hopefully later we'll have some time for Q&A. So what exactly is FastAI V2 and why is it exciting? If you haven't heard about the framework, here's a quick overview of the new one. FastAI is a deep learning framework, broadly a machine learning framework that is very extensible and can be applied to famously 4 different categories as of today. It's also one of the most widely recognized courses in this domain. The version 4 of the course, along with a book, has recently rolled out, and the framework was completely rewritten for the new course and the book. So if you've taken the course earlier or if you're new to it, if you've taken it earlier, the API hasn't changed much, at least the user API, but it's actually a complete rewrite and the internals have been rewritten. If you're new to it, you might find the layered API interesting. And this sort of sits on top of PyTorch and connects really nicely with Python even at some points. And you can learn all about these in the course and the book. I won't be talking about that. I just wanted to point out the layered API. If you look towards the right, you can see why is it known as a layered API. And even the lower layers, contrary to some deep learning framework, aren't connected with, let's say, CUDA or other frameworks. This actually sits on top of PyTorch and Python. So depending on your use case, you could just use the applications. You could use the high level API. You could use the mid level API, or you could use the low level API. Now, zooming out, why would you even care about this? When you're applying your knowledge or when you're trying to solve a problem using deep learning, you'd like to get started with a framework. Now, you'd want minimal lag between when you decide to solve a problem and when you decide to start coding it and try to get to the solution. I think this is one of the fastest way to get to it, and the layered API makes it much more convenient. So let's zoom out and try to connect this with the deep learning pipeline. Broadly speaking, there are 4 steps. Each can take quite a bit of time, but in a simplified fashion, these are preparing your data set, figuring out how can you load it into a model, quote unquote model, or your GPU and apply transforms to it. How can you go from there and further train the black box model? It's not really a black box, but let's call it that for now. So now you have the robot or the black box. You'd want to tune it a bit so that you get a satisfactory performance out of it. And you'd want to evaluate your results by looking at the predictions, maybe where it's mispredicting, how well is it doing against your metrics if you're getting satisfactory results. Going back to the API, how does this connect with FastAI specifically? Let's look at a computer vision example. So for computer vision, what you're trying to do is you're trying to apply these deep learning models, these neural networks, to image problems. Now, what are image problems? There are a wide variety of image problems. The one I'm talking about right here is image classification. So you have a few images and you'd like to detect what does the image really contain. So here's what that looks like in the API. And what I want to highlight is the convenience of getting started with the high level API. In just a few lines of code, you can get actually pretty good results. So in these lines, we're sort of preparing the data set, downloading it onto our instance, our server, our machine, and loading it into memory, followed by which you'd like to prepare it for your model. So for that, you need something that can effectively load the data set for your given constraints, for your given GPU, or for your given architecture. By architecture, I mean your deep learning model. Very conveniently, FastAI has something known as data loaders. And since we're talking about images, we'll use an image data loader. I'll show more examples very shortly, but a usual trend with anything related to FastAI is X data loaders replace X with whatever application is supported by FastAI. If I go back, vision, text, tabular, and collaborative filtering are the applications supported by FastAI. And those are, broadly speaking, the domains where we would like to apply deep learning to. Once you have the data set, you'd like to create a model based on this and train it. And for image problems, the famous architectures or the architectures that are known to work well are convolutional neural networks, CNNs. And here's how you can do that in FastAI. So here we're calling ResNet 34, which is not the best, but one of the well-known architectures, works really well for most of the problems. And finally, we can train it. So more or less in 4 or 5 lines of code, this will get you to good, by good, I mean pretty much a state-of-the-art accuracy on this problem and this data set, which is the PETS data set. We'll circle back to that shortly, but I want to highlight that there are 3 different levels of sophistication inside FastAI. Why would you care? So when you're trying to apply to a different problem, this is one of the examples in FastAI, which is why things work really well. You can work with 5 lines of code, and this works really well for most standard problems. If that's not the case, well, you can use the mid-level API, which is data blocks. And like I had pointed out, you can use a X block, which could be image block, mask block, point block, bounding box, or a text block, even a tabular block. So depending on your problem, you can actually use the very flexible API and try to solve it. There's also something known as pipelines, which I won't be talking about today, but that more or less comes in the low level API of the framework. Now that's enough talking. I'd like to jump into a notebook, a Jupyter notebook, and give a better introduction of the API rather than just talking about it and hand waving. I'm assuming everyone can see my Jupyter notebook, and I'll keep talking. Okay, so let's look at what I'll try to do is I'll try to circle around different applications and highlight 2 things. It is very similar. The API is pretty similar for different problems. So for image related problems, for text related problems, or NLP related problems. B, how can you achieve the same thing with different levels of API and help you understand how can you take this framework and apply it to your own problem. Quite a bit of stuff has been stolen from the course, the documentation, and another mini course inside of the community. So please feel free to check them out if you're interested. The first thing you'd like to do whenever you're working with a problem, and my motivation with giving an overview of this framework is you can take it and apply it to your own problem, or you probably get excited enough. If you haven't earlier taken this course, you maybe jump onto the course and see what you can do with it, or just use the framework for your own problem. So I'll try to talk about a lot of things, which means this will be a more breadth of applications. But you can absolutely dive into depth using the documentation or the course or the community. So let's first look at the problem I had just shown, which is classifying if an image contains a dog or a cat. Usually for FastAI, there's a general thumb of rule. There are different applications, and if you want to apply this to a text application, you can just go fastai.text. You could use Colab or Tabular. Let's revert this to Vision. So you'd like to import all modules from Vision. If you're coming from a Pythonic, very strict Pythonic Type 8 environment, this might seem offensive to you, but FastAI actually takes care of import star really well, and it is ensured that this does not create any issues inside of a Jupyter notebook. Since this data set is already prepared inside of FastAI, there's a convenience function that allows us to download it and get the files. So now we have the files in memory. You can check this data set out. It contains around 35, 37 breeds of cats and dogs, and close to 7 or 8,000 images. So it's a good problem to get started. Now, once you have the data set, you'd like to load it into a model. For that, you need a data loader, very conveniently named. So X data loader is the general naming trend with FastAI, and X for our case would be image. Now for this specific data set, the naming convention followed is like so. If it's a cat in an image, the first letter is capital. And if it's a dog in the image, the first letter is in small case. So we'd like to tell that to our data loader and further our model. Very conveniently, we have a from name function. And this exists because this is one of the standard trends inside the community where you can have the name of your labels given through the image names or the file names. So you need to pass the path, the name of the files, the location of the files, and a way to grab the label, which we have just defined up here, followed by a few standard transforms that you'd like to apply. I'll definitely be talking more about image augmentation shortly. For a sanity check, let's see if our images have been loaded properly, and you'd always want to do this just to double check if things are working as they should. So we have a good number of dogs in here. I'm absolutely a dog person, so this image, this ratio looks good to me. Few cats, more dogs, all good. After that, we'd like to create a model. There are different learner objects. In machine learning, you're learning about your data, so you'd like to call a learner object. For image tasks, it's most of the times it's a CNN learner. So we call a CNN learner, pass our data loader to it, define our model, and a metric which we care about, which would be error rate here. Most of the time when you're working with deep learning, you'd care about a few metrics. You can pass one or multiple ones here. Note we're using fine tuning here. So we're using pre-trained models. We're not training this model from scratch. And that's exciting because in less than a minute, we get really good validation loss or really good error rate on the problem. We're not trying to optimize the problem. We're trying to get started really quickly. So I'm more interested in showcasing the library. But even if you don't tweak things a lot, I can say more or less this accuracy is pretty good. After you've done that, you'd like to investigate your model. So models aren't really black boxes. You can see what's going in, you can see what's going out, you can even see what's happening inside of the models. But let's see, where is our model messing up? So you'd like to circle through these to understand if your data has any mislabels or actually if your model isn't working really well with some images. If it's not, you'd like to debug it and see how can you improve that. There are different ways to it. I'll skip those maybe for a later presentation. Okay, that's a simple enough high level overview, but what if you have a different sort of data set? What if you need to configure more things, or what if your format is different? Let's take the training wheels off and look at the data blocks API. So this is the mid-level API. Remember, FastAI is a layered API. You can use different layers depending on your requirement. We just looked at the high-level API. This is the mid-level API. So now we'd like to load our dataset into using a data block. How I look at it in my memory is there are different blocks that you essentially stack on top of each other and connect really well with the API and the models. So inside of a data block API, this is the same problem. So maybe it's an overkill, but it's also a good walkthrough. We'd like to tell FastAI that, hey, we're working with an image block and we're trying to classify categories. And we'd want you to get image files and randomly split the data set. You can get the labels. So remember, Y is our target variable for deep learning. You can get Y or get the labels, get the target variable using a regex labeler. That's a tongue twister. So for this data set, if you want to classify categories, the name of the breed of the dog or cat is actually encoded in the file name using a regex, and you can grab that using a regex like so. You'd also like to apply a few transformations. So image transformations are somewhat helpful in improving your models. Why and how we'll get to that in the later part of this presentation, but it's good to know that you can pass all of these options in just a data block. From there, things start to look pretty familiar. You can put all of this into a data loader. You can investigate the batch. So today we learned that there's a cat that's apparently named Bombay. Interesting. And from there, you can go ahead and train a model. I'll skip that since I've already talked about it. Now, as you can see, we're starting to see a few familiarities between these. And let's continue the trend. Maybe look at another problem. And what I'm interested in showcasing is, depending on different problems, the API looks pretty much the same. So you can take the same API applied to different problems, and when you're working with these things, you'd like to have a minimal mental model. That's how I look at it. And fastaiv is actually pretty similar across different domains. So now let's take a multi-label classification problem. This is one of the more famous data sets in the community. This is originally intended for object detection, but turns out works pretty well with multi-label classification as well. So once you loaded it into memory, you can see the labels. Ideally, you'd always want to check if your data set is loaded properly. You can see in an image, you can have different labels: a chair, a car, a horse, a person, or even a bicycle. Now, the way to load that into memory would be pretty much the same as earlier. You'd want an image data loader. But if you remember the last time we were using a from name function, this time we'd like to use a from data frame function, since we've loaded the data set into a data frame. From there, things are again familiar. You need to pass the path, the folder, locations, and maybe a few transforms. If this doesn't make sense to you, you can later check out this notebook or head over to the docs. It's very well documented and you can get started quickly. Although I hope you're starting to see the common trends between different problems. Once we've investigated the batch, loaded into memory, we can again create a model which is pretty much the same, pass a few metrics, and tune it. I'll skip the next part, come to the mid-level API walkthrough of this. So let's again take the training wheels off. I'm skipping the results in interest of the API because I'm interested in showcasing the API, not really the results. The pipeline looks familiar for almost all of the problems. So for data blocks API, let's recap. You need blocks. You need to tell data blocks what problem do you have. You need a way to split your data set. You need a way to grab your training data set and your labels. And ideally, you'd like to apply a few transformations to your data set. Why do we care about this? Maybe you don't. Maybe you have a different problem. We'll get to that maybe in this meeting, in this meetup, in this presentation. Maybe later in the future you find a problem that's worth looking into, that's along similar lines. And as you can see, it shouldn't be very hard to adapt this API to another domain. So in your data blocks API, you'd like to pass on the image block. We're working with images, and this is a multi-categorical problem, followed by which you'd like to split the data set. For this particular data set, there's a different validation folder. So you can actually let it know that, hey, inside of a data frame, we have a column which is known as valid, and just use that. And you need to grab the training files and the labels. So you can pass that to get X and get Y. The cool thing about this is if you were using a text block, which let's say is categorical. You just need to change this to text and maybe configure the file names here. And after that, we're good enough to load this into a data loader, pop it onto your GPU, train a model, and get the same results. I'll skip that. Let's look at a different domain, text, and let's see how can we get to state-of-the-art accuracies in classifying movie reviews. So we want to check if a movie review has a positive or a negative emotion. You could think of similar applications, similar interests. One would be you'd want to analyze text for sentiment. You could do that totally. There are different data sets that are already out there. You can just grab one and try it, maybe even today with FastAI. So now that we have the data set, and this data set is prepared for the course, so it can be conveniently downloaded through here. Once we have downloaded it, we'd want to set a data loader. Now this time X will be equal to text. So up until now, we were looking at image data loaders. Now we're looking at text data loaders. For this particular data set, it's split across different folders. So we have a test folder, we have a train folder, and an unsupervised folder. So we want to tell our data loader that, hey, our data set is coming from different folders. And furthermore, we'll pass on our data set to it. From there, we can go ahead, create a learner object. This time we're working with text classification, not convolutional neural networks. So we can create a text classifier learner to which we pass the data loader and the model. And in less than 5-10 minutes, we get a pretty good model with 93% accuracy. So even though you're using the high-level API, there are defaults baked into the framework that work really well and have been very, and the creators, authors have been very thoughtful about making sure these work really well and get you to higher accuracies. But for some reason, if this API doesn't work for you, you can again get to the mid-level API. Just doing a comparison, now you need a text block and a category block, and other things remain pretty similar. This is one of my favorite names inside of the API, grandparent splitter. So the dataset is actually split based on the grandparent folder, if that makes sense. Now that we have the data block, you can pop that onto a data loader and train your model from there. Let's look at another example, this time for tabular to keep the continuity. You'd want to import tabular from fastaiv2. Now, so far we've seen image, text, tabular. There's collaborative filtering as well. For tabular, you'd want to import from tabular, fastaiv.tabular.all. As expected, you'd load the dataset using tabular data loaders. Adult dataset actually contains different details about your social status and connects that with your, not your, but from the dataset, different social status of people and how much do they earn based on these. So you're trying to predict that. So once you have the data set, you can set its path and you're trying to predict their salary based on these. Maybe you work for a bank or maybe you're just competing in a competition. This is part of the competition. In almost all of the tabular data sets, so by tabular, I mean where the data set exists inside of a data frame or it's just an Excel sheet, you have different variables. For this, you can imagine there are a few categorical variables and a few continuous ones. So categorical variables are where different categories exist. So you can be a high school graduate, you can be a college graduate, you can be a PhD, for example. Continuous ones are where the numbers are continuous and not actually categorical, although I could argue that age can be put under both. For tabular data, you'd also like to process these. Think of these as augmentations for your data set. So you'd want to pass that as well to the data loader. And from there, you can pop this onto a learner and create a model. Now, this was a very high level overview, more of width based, more of a breadth based overview of the framework, but I was trying to cover all of the applications. These are different applications that are supported by FastAI. And as you can see with the mid-level API, you should be able to extend this to, I would virtually say, any problem. If you'd like to know more, please head over to the documentation, or you can find me after this meetup, and I'd be happy to discuss about further details. So for the second part, I'd like to jump back into my presentation and give an overview of why image augmentation is even important. So why do we need image augmentations? We looked at a few problems. Let's try to rewind our minds to the image classification one. For image classification or similar image-based problems, depending on whatever use case you're working on, it could be segmentation where you're trying to detect individual pixels, or it could be a regression problem as well, where you're trying to just find a point, a continuous point. One of the challenges with deep learning is making your model generalize well. So let's say all of your data set has just yellow cars. How can you make it generalize to cars of any color? Second problem with image related data sets is sometimes you have less data, although usually you would have more data than you'd expect. So how do you solve this problem of having less data or small data set or lesser examples in your labeled data set? The third problem is how can you create a better test set that can represent the world or prepare your data set for certain problems for which it's not intended. So let's say you just have photos of cars in the wild, but you're actually trying to build a number plate recognizer. How do you do that? Well, the answer is image augmentations will look at all of these examples. But essentially with image augmentations, you're trying to take your training data set, change it just a bit, maybe rotate it, flip it, or just change the colors even. And these subtle changes are good enough for your model to generalize better. And virtually that solves all of the problems stated. So here's a list of all of the augmentations supported in FastAI. I'll skip these and jump into my notebook again to give actual walkthrough of where these are useful. And these are a few use cases that I'll try to cover. So let's say you're trying to build a swimming pool detector for some reason, or you're trying to find an empty parking lot. Or let's say you're building an OCR for medicines or an image search engine. How can you use a dataset better for these requirements? Jumping back into my notebook, here's the complete list of augmentations currently supported by the framework, although you can conveniently write a new one as well. These words may or may not make sense, so I'm going to scroll past them, and what I'll try to do is we'll use a reference doggy image. I found a beagle that looked pretty cute, so we'll use that as reference, and I'll try to come up with a few suggested use cases that sort of make sense for that particular image augmentation. So I'm skipping past the boilerplate code that loads this image into memory. It's more important to understand for this meetup. It's more important and intended that you understand where these can be used. So here we have a cute beagle. Uh, I don't know what he or she is looking at, but we'd want if you want to flip the image, this is how a flipped image would look like. Well, it sort of makes sense to flip your doggy image at least horizontally, but let's say if you want to use this for a more realistic use case, you're trying to build a swimming pool detector. I'm not sure how visible it is, but the blue part here in the image is actually a swimming pool, if I remember correctly. This is one of the problems that I've actually worked on. And if you flip this image horizontally, this, for the model at least, is a completely new image. So going back to the challenge with datasets, this actually helps create almost virtually a new dataset. Let's look at dihedral flips. So if you've painfully studied, or if you've been forced to study chemistry in 11th grade, you know what a dihedron is. If you don't, well, I'm happy for you. But there are different angles in a dihedron, and essentially 8 different angles. So we force our puppy to go through these unfortunate 8 rotations, which doesn't really make sense unless for some reason you'd like to have a wallpaper like so. Although I couldn't imagine who would want that. Let's look at a satellite image where it make more sense. Now, the goal of any augmentation is to create almost virtually a new example. So your model would want to learn something new from a different example, and at least to even to a human, you could argue that these look like completely new images, and these are very helpful for your models. So this gives us more progress in our swimming pool detector experiment. Remember, you're not using just a single augmentation in practicality. You're applying a bunch of these to different batches. So as you do that, you'd want to consider which ones make more sense for your use case. Now, if you're working with text dataset, rotating it upside down wouldn't be helpful at all. But for images as such, satellite images, etc., this makes quite a bit sense. The next augmentation supported inside of the framework is crop pad. So you crop into an image and you pad it with zeros. Zeros in the world of images is black pixels. So we see black pixels here. Let's look at an example. This is actually a medicine from my home. Just for copyright purposes, I just took a picture of this because that made more sense. And let's say you're working on different problems involving trying to figure out has this expired or not. And this is a problem that I've actually worked on. The images were sort of more tricky. This is a better image, but as you can see, cropping into different locations is pretty helpful for this image. You could also resize with different options. You could apply a border, you could reflect it. And in my experience, the reflection uh, padding is most useful for OCR as long as your text is in the middle. So OCR stands for optical character recognition. You're trying to recognize if this particular medicine has expired just by reading these characters. This is one way of making it easier for your model to be able to detect this text. You could do a random crop into your image. In my experience, this isn't very helpful for at least OCR problems, but maybe it can be helpful if you're trying to find where the text is exactly located. So there are different options for resizing as well. This is a resize augmentation. You could squish your image, literally squish it into a certain shape. You could pad it or you could crop it. This is putting together all of the augmentations that I've just shown. Now you're trying to build, let's say, an image retrieval engine. So based on a photo that you've clicked, and this is one of the recent, I'd say, apps rolled out by a company. You're trying to take a picture and find it on the internet. Let's say you're trying to find these cornflakes. This is an okay-ish image, but as you can see, trying different resizing options is pretty helpful depending on how the image is oriented. All of these problems sort of originate based on the fact that humans never really click pictures, assuming that they're gonna put that into a CNN. Literally, after this presentation, try to think of this fact when you're scrolling through the Instagram stories, right? You don't see anyone posing in a very linear fashion. That should work really well with a CNN. So you don't want to apply these augmentations to help you get the most out of your model. Another one can be random resizing and cropping. This is actually pretty useful when you're working with number plate recognition. I haven't included a photo because that creates some copyright issues and I wasn't sure of that. But as you can imagine, people put up number plates on their vehicles in different locations. You'd want to crop into different centers to be able to find them. Or you could also experiment with your OCR problem to see how well that works. Another one is ratio resize. So now our beagle puppy looks really big because well, I've resized it to an almost HD size image. Depending on your problem, if you resize it to a bigger size, as long as that's not greater than the source image, it's always helpful for your model. All of these were transforms that are applied to individual items in the API. You can also apply these transforms using a GPU. So on a complete batch, that's of course much faster. You'd almost every time want to use these whenever you're working with a deep learning based problem. So I'll skip past these in interest of time, but just I'll name these in running. You can do random resize crop on a GPU, so apply it to the complete batch. You can do a deterministic flip for and as you can see, this is pretty helpful for image search engines. You could do a dihedral flip. And remember, the difference here is you using this on a GPU. So when you're passing options to the API, you can just pass on a batch transform and you get these different options. This is actually, again, useful for satellite images. Different validation flips and different training flips or augmentation. So when you're training your model, you'd always want to include as much randomness. But when you're trying to run this model on a validation set, you wouldn't want the randomness and you'd want your results to be deterministic in order to be able to compare them against each other. So I'm not really diving into depth about that, but actually there are options to deal with it inside of the API. This is another interesting one. You can rotate your image by a few degrees. This sort of looks like an image that someone would post on Instagram, maybe so. I'm not really up to the trend these days. To me, it makes more sense to apply to a satellite image that I had shown earlier. So you could do that. You can also scale and zoom into and out of an image. And remember this happening on a GPU. For OCR problems, this sort of almost makes sense because you'd want your text to be as large as possible. And you can zoom into different centers. I've already talked about this. You can do this on the GPU. There's an interesting augmentation that takes some time to wrap your head around. It's known as warping. Interestingly enough, it sort of warps your image vertically or horizontally into different angles. This is actually pretty useful when you're taking an image or when you're working with images that aren't linear or vertical. So the object is sort of tilted at an angle. So you're doing 3D rotation of your image in a 2D format. That's the closest explanation that gets as intuitive as it is. You could do this horizontally as well. So horizontal warping for this image sort of makes more sense. The magnitude 0, I think, makes it the best. You can play around with the brightness of your source image. And for our OCR problem, I think the brightness of 0.5 makes more sense. You could play around with contrast. I think this almost looks like a filter. Although this is very helpful when you're trying to read text on a shiny background. So as you can see, the most contrastive image is pretty helpful. You can try to saturate your image. This doesn't really look that well, but for again, For text problems, saturating the text in my experience has been helpful. This one is interesting. I couldn't come up with a good example for this, but you can transform between color spaces. Not all images are RGB. You can transform between different ones if required. This is just a trippy version of our dog. It sort of makes sense when you're working with images that have a uniform color. So if you want to ensure that beagles with green background are recognized, maybe you could try this. I haven't, but I think I can see that it might help the model a bit. Now, these are one of the recent developments. This is known as cutout. So essentially just cutting out a portion of your image. This is helpful in ensuring that your model just doesn't overfit to one particular part of the doggy. So for example, if your model just assumes that a creature with a tail is a dog, randomly cutting that out is helpful. Random erasing is a similar variation of this, and it just ensures that your model doesn't overfit to one particular feature. The final thing that I want to point out is you can also do test time augmentation using a learner object. So we looked at the API in a very brief format, but you can also apply something known as test time augmentation. So while you're trying to run augmentations on the test dataset, you can call this function and it sort of takes care of a few nice details where you wouldn't have to worry about ensuring that the augmentations are done in the correct fashion or they aren't random, and this ensures that these are deterministic. So this was a very brief overview of the augmentations. I'd again encourage you to check out the documentations on this, or I've written a Kaggle kernel on image augmentations in FastAI. You can check that out as well if you're interested. So circling back to the use cases, we've looked at these four different suggested use cases where these can make more sense. In general, you'd always want to apply a bunch of augmentations to your dataset. How can you know more about these? Well, through experience and through understanding your dataset, and also seeing what works best. So cutout is still or could be somewhat counterintuitive to you, but I think it works well for quite a bit of use cases, maybe not for text recognition. So the best way would be to try and experiment and see what works best. So I just want to point out a few more resources before concluding this. The latest version of the course has just launched. You can check that out at course.fast.ai. There's another great mini course by Zach Mueller called Walk with fastaiv2. This is also on the course, the community, the fastaiv community, and I'm actually hosting a few study groups around the course. So if you just join the Machine Learning Tokyo community, you should be able to find these. I'll try to grab the links to these, but if you just look up Machine Learning Tokyo on the forum, so if you head over to the forums and search for this, you should be able to find all of the links to these. So this was a very brief overview. I hope this got you excited about maybe the framework or image augmentations, and I think we have a few minutes for Q&A if there are any.
Awesome. Thank you, Sanyam, for a wonderful presentation. Let's just flash your contact information once more, because there's a few questions regarding that, how to get in touch with Sanyam. And there's a few members in the audience who have large questions, which we will not be able to cover just yet. So please, let's just note down Sanyam's contact information for any questions that do get left out. And now let's just dive right to it. First question. I note that most examples resize image to 2 to 4. How does it internally perform for larger image sizes, as resizing causes features I'm interested in to disappear?
In that case, you wouldn't want to resize to a smaller image. There are two things. So to a human inspector, the features might look like they're gone. The models are really good at capturing these, so you'd want to be cognizant of that. Otherwise, you can play around with cropping into the image. So let's say you're trying to find features in an image, and by features, let's say you're trying to find swimming pools inside of a satellite image. You can crop into just different regions instead of resizing the image, if that's helpful.
Awesome. Next question. Is your OCR code for medicine print recognition available on GitHub?
No, it's not. I made money through it. It's proprietary.
Wonderful. Well, I'm sure that's helpful to a lot of people. Can we apply augmentation for non-vision domains and also for domain where non-vision data is converted to images?
Absolutely. You could. I'm not sure where it will work best and what are the best practices. And I haven't read materials about this, so that could be a really good blog post if you end up experimenting along that. For text, there are different augmentations which are unrelated to images. Just to mention them, you could take a text in a certain language, translate it to another language, sorry, and translate it back to English. Now, just because these translators work so poorly, you get some differences which work really well for models. So that's one of the text augmentation techniques.
Thank you. Now, next one is a three-part question. Let's begin. I have an electronic chipboard with lots of small devices. Number one, how do I label those objects within an image or with an image? It's not completely clear, but I'd let you take a stab at it.
That's a great question. And working with your own data is sort of very helpful. You could look at different open source options. One of the closed source ones would be Prodigy. I've tried it. I really like it. So you could use these options to try and label your problem. I'm guessing you might want to work with bounding boxes on these.
Okay, next part. How to teach to categorize each object in an image?
I didn't get that question, sorry.
Will repeating help? How to teach or train to categorize each object in an image?
Maybe the question isn't clear, but I'll take a stab at it. There are different options inside of the framework. You can let the API know that it's a categorical problem, and there are defaults that sort of configure it into that.
Wonderful. How fast AI is different to TensorFlow for this use case?
I haven't tried TensorFlow, so I can't answer that question extensively. But if you're coming from a PyTorch framework, I like the flexibility of it. So maybe, and last time I checked, PyTorch was more flexible than TensorFlow, even though you can argue against me, I would disagree. I think there's more flexibility for different problems, especially image ones.
Awesome. So everybody, please note, he loves to argue over chai. If you really want to spend some quality time, head over to his Twitter or Kaggle handles and ping him. Next question. What would be your suggestions for the number of images needed to start a POC, for example, for an OCR project?
How so many ever you have with minimal efforts are good enough. POC is called POC for a reason. Whatever you have, try to make things work. If they don't, then try to scale up or otherwise kill the project.
Thank you. After cropping, only part of the images are left, like legs or the body of a dog. If we add the image into the training set, do you think it will lead to bad performance of model?
If you're not doing it right, yes, which is why you should probably investigate into what's going on, which is why I showcase these. So you'd want to look at a few batches, and I had shown the functions very briefly, but you'd want to see what's actually happening when you're doing these things and not just throw them at the model.
Thank you. How to process large size image augmentation?
Pay a lot of AWS bills and get a big server.
Well, I'm sure everybody has the same concern regarding AWS bills. How does this compare with computer vision APIs, for example, from Google?
Um, Many things do this. I'd say many APIs do the same thing pretty conveniently. You'd want to stick to the one that works really well for you. So if you tried different ones, just use them. If you see that this API does something better, maybe experiment. I like the path of least resistance. For me, that's fast AI, so I try to stick with it as long as I can. You can experiment and see what works best for you.
Great, thank you. That's great advice. How can I get API key for FastAI v2 framework? And how is it different from regular data augmentations?
There's no API key. This is completely open source, so you can just install it. It's I don't know of the other standard, so it's there's no straightforward comparison. It's a framework that sits on top of PyTorch.
Okay. How is FastAI different from PyTorch? Just mentioned it.
It includes a lot of boilerplate code. So with PyTorch, you'd end up almost always writing data loaders. Even with FastAI, you have to, but these are less comprehensive and minimal compared to PyTorch. So it eliminates a lot of the boilerplate code that you'd end up writing, which you could if required, but you don't have to with the framework.
Wonderful. What are some of the top use cases, I'm assuming? It says usage examples, top use cases of image augmentations, and how can I better use it?
That's a great question. And for images, one of the problems is like someone had mentioned working with a specific domain problem, right? Let's say identifying PCBs on a electronic board, and you're trying to find defects, etc., etc., etc. You'd have quite a few images, not as many as ImageNet or otherwise. So you'd like to get more examples. And if the person goes back and labels their images, they'll realize that it's time consuming. You wouldn't want to spend that much time, so you can just instead do an augmentation instead of sitting down for hours at end and labeling each individual image over and over.
Thank you. Can you suggest some sample code to practice generative adversarial networks?
I like copy pasting a lot. You can find a lot of boilerplate code on the community, even on the FastAI community.
Wonderful. The next set of questions are asking for slides, recording your notebook and your slides. All of this will be shared shortly after. There's another one asking for the link to the machine learning forum you referred, and the link to the Tokyo Machine Learning Study Group.
Sure. I'll try to include a slide, so once these are up, you can grab all of these through that.
Wonderful. We'll send all these out. Now we're in the last leg, or last half a minute rather. Do you have any concluding thoughts before we wrap up?
Thanks for joining. Stay safe. Please take showers and not just change clothes. Don't change your hairstyle, change your clothes. And thanks for joining on a Tuesday morning.
Well, that's wonderful advice. Take showers. Thank you everybody for joining. Thank you, Sanyam, for a wonderful presentation. This was very engaging. We'll see all of you very soon. Take good care. Bye.
Thank you, Saurabh.